Hi guys. Alright, in your textbook, 54. So get your books out, page 54. Also, you're going to want to have out this document right here that we worked on yesterday. So make sure you have that out, because you're going to be using it as a resource to answer these questions. Okay? So it says use the characteristics provided to choose the appropriate function family or families from the word box shown. So for example, part A, the only clue they give you is that the graph of this function family is a smooth curve. Okay, so out of these four choices, which graphs are curved? Choose the two graphs that are curved. Okay, so that would be quadratics. Oh. Yeah. Exponential or quadratic. Let's do this. Quadratic and exponential. Okay. The graph of this function family is made up of one or more straight lines. So what has one or more straight lines in it? This is where, if we're in class, we're doing a pause. I'm making today's video for two purposes. One, I have to miss period 5 today because I have a meeting to attend. And I want you to have this to look at later, but the wording today is going to sound a little bit differently because I'm in classroom mode as well. Okay, so you might be pausing this video if you're period 5, if you're watching this in period 5, because of giving you time to figure out the answers. Okay, so the graph of this linear function family made of one or more straight lines. It could be a linear function, or it could be linear absolute value. Oh, you know what? The graph of this function family increases or decreases. Not both. Increases or decreases. This would be a pause point. Increases or decreases, not both. So that's going to be linear and exponential. The graph of this function family has a maximum or a minimum. Pause. Look in your chart. That's going to be quadratic. And linear absolute value. Okay, the next part you're given more clues. It says number 2, a second characteristic has been added to the graphical description of each function. Name the possible function family or families given the graphical characteristics. So A says the graph of this function family has a minimum or a maximum and it's a smooth curve. So pause while you look for the answer. That's quadratic. The graph of this function family either increases or decreases, not both, and is made up of a straight line. Pause. That's a linear function. Okay. At the top of the next page, we have two more. We have C and D. The graph of this function family is a smooth curve and either increases or decreases over the entire domain. So it's not linear. Okay, we just did that. It's a curve. Okay, pause, see if you can figure it out. That's an exponential function. The graph of this function family has either an absolute minimum or an absolute maximum. It has symmetry, in other words, both sides look the same. And it is made up of two straight lines. Pause, see if you can figure out which graph that is. What kind of graph is that? That's linear absolute value. Okay, now we're on page 56. This box right here is pretty important. Okay, linear function exponential, because this next part, and you're going to have to do this on your homework too, you're given a little creative license to write some equations. Your homework answers might be different than your neighbors. And so the format is going to be important. Every time you're writing an equation, you might want to refer back to this chart to see what should it look like. Okay, so for example, if you're asked to write a linear function, then m and b could be numbers that you have some creative license to make up. Exponential functions, you need to come up with an a and a b. Okay, when you're creating them, you're coming up with whatever you want it to be. Again, I'm going to encourage you to have this chart out and looking at it, because extra information we wrote here might help you, but the chart itself is going to help you as well. So I would recommend having that out. Okay? Quadratic, A, B, and C are things that you can make up. Keep in mind, quadratics have an exponent of 2. Linear absolute value, you make up numbers for those things, but if it's an absolute value question, it has to have absolute value signs with the x in it. Alright, so let's recap. Linears are mx plus b form, no exponents at all. Exponential functions have an exponent of x in them. Quadratic functions have an exponent of 2 in them. And linear absolute value functions have absolute value symbols in them. So if I was doing the next part, it says in A, create a sketchograph that is a function. Well, that's kind of a Captain Obvious. Is exponential, is continuous, and it is decreasing. Okay, so let's see. Exponential functions, I look like this. So I'm going to start off thinking to myself, okay, f of x equals a times b to the x. Okay, so what I need to do now is I have the correct format. Now what I need to do is come up with values that I want to use, and this is pure creativity here. Pure creativity here. Come up with values you want to use for A and B. One thing I will tell you is for B, don't make B negative. B cannot be negative. You'll get a crazy graph if you do that. Okay, B cannot be negative. So I'm going to say that I want A to be 2 and X could be 1.5. Well, gosh, how do I graph that? Well, that's where we're going to use our handy dandy TI-84 calculators. I'm going to show you how to do something new on the calculator today. So go to your y equals and type in whatever equation you made up. 2 times 1.5 caret x. Okay, now looking at the graph is not ridiculously helpful because I don't know exactly what this point is right here. I can tell that this point is like a decimal, so I'm not really sure. So if I want exact points, I'm going to hit the second key, and see how it says table above graph? I'm going to hit that. And it gives me a list of values that I can use to graph with. In fact, if I scroll up, I can see negatives, zeros, and positive. Now, I did make up one that has some kind of ugly decimals in it, but we can round a little bit. Okay, so if I were making this graph, I would draw in my axes. Okay, I would highly encourage you to number them, but I'm not going to take the time to do that right this minute. Oh, I got to keep my calculator and change the view to always in front. There we go. So now I'm going to start graphing on this. Like this says -5 and 0.2634. So I'm going to have to estimate where I think that is. I think that's about there. And -4 and 0.39. Okay, that's like 0.4. -4 and 0.4. And it's going to be really hard to make these two look that much different. -3 and 0.6, so a little more than halfway. -2 and really 0.9. -1 and 1.3. So just kind of estimating. 0, 2. 1, 3, 2 and 4.5, 3 and 6.75, so 1, 2, 3, 4, 5, 6. Okay, and we kind of have enough points right now that we can draw a reasonable curve. Oh, I missed it a little bit there. You can draw a reasonable curve. Okay, so let's look at another one. Pause if you need to. All right, let's talk about an equation that has a minimum. So right now I'm thinking of either a quadratic or an absolute value. Is discrete, so that means I'm not going to connect my dots. And is linear absolute value. So that means that I'm going to make up an equation that has absolute value symbols in it. So let's say this is the one that I make up. Then I'm going to go into my calculator, go back to my y equals, clear out the old equation, and whatever one you made up, okay, if it's not mine, use whatever one. Okay, to get absolute value, remember a second catalog, and absolute value is the very first thing in the list. So click that, and look at there, you got your bars. So then you'll type x minus 1, arrow out, then plus 2. Okay, and you can look at the graph if you want. All right, but since we want to do an exact graph, we got to go to the table and pull some values out. And we would start graphing. And then because it's discrete, that's what it ends up looking like. Okay, now depending on, I chose, well, the book chose, I should say, to label every other line. You didn't have to do it that way. You know, just using the graph space appropriately is fine. The important thing, no matter how you numbered it, if you counted every other box by ones or you counted every box by ones, the important thing is that we got discrete here. Keep it discrete. Okay, so again, where did the -1 come from and the +2 and there's supposed to be an A out in front here. Well, there doesn't have to be an A out in front, or you can think of it as an invisible 1. You might have written x plus 1 and minus 3. So this is your opportunity to just get creative, put in numbers what you want to see or what you want to use. My advice to you would be keep it small. Stick with numbers like 1s, 2s, 3s, and so forth, because you don't want to make your functions grow so big and get to be really big numbers. So when you're being creative, don't go overboard and use really big numbers. Okay, the next one. Okay, we've got D and E. Oh, how did I skip C? Okay, C is here. Create an equation and sketch a graph that is linear, discrete, increasing, and is a function. So yesterday in our chart, we talked about how M, the slope, the rate of change, if it's going to be increasing, would have to be a plus. I didn't want to do that. Okay, so maybe you write an equation. So M is 2. I said keep these numbers kind of small, and your y-intercept could be a plus, could be a minus 1. Now it says increasing, so my M should be a positive number, and x as an integer is discrete. Okay, the ones where it says is a function, I think we can kind of safely eliminate these, because those words aren't really a helpful clue, because they're all going to be functions. Okay, so again, I'm going to go into my calculator, and let's adjust the size here. Type into your y equals 2x minus 1, or whatever equation you wrote. Hit your table, and then you've got a series of points that you can plot. Again, keep those discrete. Do not connect them. One thing I think the textbook should have done to be really proper is to continue putting dots to the edge of the graph, because it does not indicate anywhere that those dots wouldn't continue. So they should probably be more dots than the textbook is showing. D, it says create an equation and sketch a graph that is continuous, has a maximum, is a function, we can ignore that, and is quadratic. So quadratic, remember guys, if you're ever not sure how to write the function, go back and look at this chart. Let's see, quadratic has to be something with an x squared in it. Okay, absolutely has to have x squared. You can keep it as simple as x squared. You could have a coefficient in front of it. Again, I would really recommend you keep those very small. You could have the bx term, the c term. Okay, so the one that I'm going to use for my example is, well, come back here, negative x squared. Remember, the negative out in front is what's going to make my parabola have a maximum. So I just show the graph already done, but if we go into y equals, clear it out, type negative x squared, then go to your table, and it gives you values to plot. Obviously negative 5, negative 25 doesn't fit. Neither does negative 4, negative 16, unless you renumber your axes differently to make these fit. Like if you made this count by 2s on every one, or by 5s on every line, you could probably fit more data. But this is enough. You can just scroll through and use the points that you can fit. So negative 3, negative 9 is probably the last point I can make fit the way that this graph is numbered. Okay, and part E, our clues were to create something that is not a function, is continuous, and is a straight line. So a vertical line is something that is not a function, it is a straight line, and we connected it so it is continuous. And vertical lines are x equals lot numbers. We can't really put that in the calculator because it's not a function. We can only put functions in there. But to graph x equals 3, you just go to the 3 on the x-axis and drop a vertical line in. So that would be not a function. Okay? For homework, the first part of your homework, this is your word box, and you're going to use the clues to fill it in. So the graph of this function family is a straight line. A straight line. That's linear functions. So there's only 4 choices in the word bank. You will use these over and over again based on the clues. Okay? So that's that part. The next part says create an equation. Okay? And sketch the graph for the function with each set of given characteristics. Use values that are any real numbers between -10 and 10. So that means your A's, your B's, and your C's in these formulas right here. They're saying you can put numbers from -10 to 10 in there. I'm going to really encourage you to stick to small numbers. Stick to small numbers. I'm also going to say one more time, this chart and some of this extra information that we wrote in is going to be helpful to you. So have that out while you're working on that. So this says create an equation and sketch the graph that is a smooth curve. So let's see, right now I'm thinking exponential or quadratic. Is continuous, okay, I'll connect the dots when I plot them. Has a minimum, okay, exponentials don't have a minimum, so that means it's quadratic. Okay, so answers will vary. You could have written x squared plus 5. You could have written x squared, 2x squared. There's a lot of variation you could have put here. All right, and then to make the graph, you're going to use your calculator for whatever you wrote. So x squared, second table. And again, scroll through and fit what you can fit. You have freedom to number things the way that you want. You don't have to count things by ones if you want to try to fit more points on there. And then use the table. Again, the default mode is for your table to start at 0 when you first see it on the screen. But you can use your up and down arrows to see more positive and negative numbers. So let's say we were doing the next one. The next one, let me minimize this. Number 12 says is linear. So I should be thinking of mx plus b. So f of x equals some sort of mx plus b. I would keep your m and b small numbers. It says it's decreasing, so I'm going to put a negative. Negative 2x, and then whatever number you want. Keep it small, plus 3. Okay? So I just made that up. You can make up the m and the b. Do pay attention to things like decreasing would mean a negative. Increasing would mean a positive out in front. So then I'd go to my calculator, open that up, go to my y equals, clear it out, and type in -2x plus 3. Second table. And now I have a series of points that I can graph. Again, scroll through whatever you need to graph them. Discrete would mean, though, specifically, pay attention to that. Discrete means I'm not going to connect my dots. Okay? The last section of this is pretty easy. It's just writing I'm not even going to make you write a sentence here. Just tell me what function family you're seeing. So this is a quadratic. This one would be linear function family. That's all it's asking you to do in that last part. So just a reminder that this video was made to teach my 5th period class, since I am in a meeting today, and help both my classes if they get home and are struggling on the homework. I hope you have a great day, and I will see you tomorrow.